object. I don't have.
Okay, so today we are going to get started with our project work. Okay, so idea behind this project or this pipeline is see in real time also you will find this kind of solution only. Okay, I'm not talking on the level of complexities or on the level of data sizes. I'm talking about the on the level of concepts and the design and the architecture. Okay, so we are going to have a data on S3 bucket. Okay, this is going to be in CSV format array. This is going this is going to be in CSV format, and this is going to be raw data. Okay, your raw data is going to be on S3 bucket. Okay, here I have most simplest of the file because I do not want to enhance the complexities on the column level. So we have a very simple file. What we are going to do with that file is we are going to write AWS glue job. Okay, we are going to write a AWS glue job that is going to do below things. It is going to apply SED2 logic. It is going to convert into Parquet file format. This is going to put data to Redshift, and this is also going to create meta info in DynamoDB. So 3 to 4 actions this job is going to take. Okay, and we are going to also write the output on S3 bucket. Okay, the third point of this job. And basically from here we are actually going to copy this into Redshift. This process of S3 Parquet files to Redshift tables is actually done with the help of AWS glue job only. Okay, so please do not get confused that first we are writing the data into tables with the help of AWS glue DL, then why we are writing into Parquet, and then why we are having these steps separated. So basically this glue job itself is going to write the output files onto S3 bucket in the Parquet file format first, and this glue job only is going to take the files into respective tables on Redshift data warehouse. Okay, here actually we have 2 layers. Okay, if you want you can create a in between layer as well. Let me just push it a bit on left. Okay, so usually in projects we have either 2 or 3 layers. So this layer, as I mentioned, is called raw bucket or your raw data, or if you talk in different different terms, it might be bronze bucket, or it might be tier 3 data. Actually we kind of label this in 3 stages. Okay, the raw data, or your curated data, or your analyzed data. Like this is what my project used to call this: raw, curated, and analyzed. So this is going to be your analyzed. Okay, this is going to be your analyzed layer here on the S3, not analyzed, it is analyzed. And from this point, actually we push the data into for analytics and Redshift. In between, you can also introduce one more layer. Okay, that is your on S3 only. It is curated layer. If you want, okay, you can involve this layer as well. So what happens in this layer mostly? Here we have almost absolute raw file, but let's say you want to do some analytics. Let's say we have 50 columns. Okay, and we might be needing only 20 columns out of those 50. for our analytical part. Like we might be doing using only those columns for our joins, grouping by, or some calculations or creation of the views. We might be using only 50 views or column. So on this layer, okay, from S3 to curated transformation. This again happens with the help of AWS Glue only. Okay, we can convert here data types of our columns. We can deselect or only select the columns that we need to be pasted here on the curation layer. We can write some validations rules here, like a columns complete data should be of integer type only. Column should be in correct date format. Some small checks. Some is here we are not doing any sort of filtering. Okay, first of all, understand that part. We are not filtering data based on any conditions. We are simply doing some small checks, some validations, and some quality testing. That's all. Okay, you can convert this, and here also you are going to write this into Parquet file format. See, one thing you have to understand. Whatever kind of data you read from your source, be it CSV, TSV, JSON, XML, API, database, if you're writing it onto S3 as an output, it should always be a Parquet file format. Okay, this is one you can say hard-coded rule. Okay, you cannot change that. Okay, so whenever you're writing some output on S3, it should always be in Parquet as much as possible. So first of all, I'll wait here. If you have any questions still here.
Sure. Jalaj, can you explain at line number 12 what is SCD to logic?
Okay, so you haven't worked with databases?
Yes.
Okay, this is slowly changing dimensions.
Okay.
Okay, so you haven't worked with slowly changing dimensions?
Might be I'm not able to recall that name.
Okay, do not worry. When we reach on this level, I'll explain you. Okay.
Okay. And this is the part we are going to cover in 2 days only, or this is going to take?
This is the complete process. We might take around, including today, 3 to 4 days.
Okay, fine. Do we have any document around it, like draw how for
Actually, I haven't drawn it anything. So we have any questions? Okay.
Not on this challenge.
Yes,
But
please.
we have not yet covered EMR, right?
Yeah, EMR is actually pending. Yes.
Okay.
Okay. So actually, we are not going to have ENF in our solution. So this is I'm going to remove. Just wanted to give you a glimpse. So I mean, if you call this, you can also call it bronze, silver, and gold layer. You can call this raw, curation, and analyze layer. You can call it different names are given by different projects. Okay, so you can use any one of those. So if I remove this, what we are going to do, once our file is going to come in S3 bucket, we are going to trigger a Lambda function that eventually is going to trigger our glue job. Okay, So we are going to trigger a Lambda function from like as and when the file arrives in S3 bucket, a Lambda function going to get kickstarted, and that is going to get trigger our AWS Glue ETL job. AWS Glue ETL job is going to perform all these things, and finally we will have our data into Redshift for analytical purpose in Redshift data warehouse. From this point, you can say that data was consumed by machine learning teams or Power BI teams. You can say that I was also responsible for creating the views on Redshift cluster. So this is about the context of the project that we are going to solve. Okay, and trust me, this is the pipeline of 80% projects. Okay, there might be small changes in there, such as instead of Redshift, they might have Snowflake. Okay, instead of AWS Glue, they might have EMR. Okay, and instead of having Meta Informer on DynamoDB, they might have it on Athena. Okay, so if you understand these processes, like if you understand the concept basics, you can create any sort of pipeline, okay, on AWS ecosystem. And same thing if you try to go on Azure, this is going to be your ADLS. Just giving info. This is going to be Azure function. Azure Data Factory, Azure Data Bricks, or Azure Synapse. Azure Synapse also provides ETL. Okay, again this can be Synapse, or it can be Snowflake. Okay, and it is going to be ADLS. I mean, kind of completely you can ignore this part. Just giving you FYI. Okay, so let's move ahead. Okay, so this is a data set that I have. Okay, it's a data of just 3 columns. We have listing ID, we have price, and we have neighborhood full column. Okay, I mean the address of neighborhood that Airbnb room is listed on. This is the data. Okay, now let's move towards the code. So see, what happens, if you have worked with databases, okay, you might know there's a concept of calling SCD, that is slowly changing dimensions. Okay, that basically means, let's say you have some columns in your let's pick up this data only. Let's take some data from here and copy it here. Let's do it like this. So let's say we have this data, okay, and I would append, let's say I get this data on day 1, and I append this data into my data warehouse after doing some transformations over this data, and that is going to be loaded there. Okay, now what happens when second day, okay, on day 2, because this is going to be continuous process, pipelines are going to be run on some frequency, whether it's a daily frequency or weekly or monthly or bi-weekly frequency. Pipelines are going to be run like that. So what if on the next run of the pipeline, I get my listing ID updated? Okay, like this is the value today for 5295. This is the old value. But what if in the next time I get one more row inside my source file where the price has been increased from $150 to, let's say, $170. Okay. Now your data warehouse is already having this data. Okay. So just a second. Let's make it more specific. Okay. I'm going to remove it from here. and this is your day 1 data. And let's say we are not doing any ETL, okay, and we are directly loading this into our target system. This is our target. Okay, this is our target system. Let's say on day 2 we get few more rows. Let's pick 5 rows. Let's say on day 2 we get a file that something look like this. Okay, this is the data from day 2. So right now it's all new data, but what if one of our ID is there, okay, that has price being increased. Now this is the case of updated details. Okay, here this column is like updated. What if like we have two cases here, okay, these are new records and this is the updated records. Okay, so we have two records, new records and updated records. Now we would like to update our system on Redshift target. Okay, there's actually one more case of delete records. I mean, in that case, what happens? You receive the full file daily. That means day 1 and day 2 file will be appended at the source. And if some record is not present, like let's say this record is not present itself, then that record will be marked for the deletion activity. Okay, but let's first understand the new and updated one. So what this concept is called? It is called SCD. That is slowly changing dimensions. Okay, that means your data is slowly changing every day. Okay, or you have the possibilities where your data might change every day. Okay, so to maintain the history of that particular thing, or if you maintain the that particular state, you have variety of slowly changing dimensions. You have SCD1, SCD2, SCD3. SCD1 is the simplest form, where what you do, you simply delete and insert. You can say this concept is called delete and insert. So I'll write SCD here. No history is maintained. Okay, and it is kind of delete and insert. How your target is going to look, for SCD1, you will be picking up this record and let's paste it here. You will be picking up all the new records from the source and you're going to paste them here. Okay, and you're going to like the rows which are like you consider the listing ID as a primary key. The primary key which are already present, like 7322 is already present here. Okay, so you will be deleting this row. This row will get deleted, something like this, and its new value will be pasted down here, and this is going to be called SCD 1, slowly changing dimensions 1, where you maintain your target table with SCD1 logic. You do not maintain any history, like this will not be there, and you simply keep the latest version of your primary keys value. And for this case, this is the latest version of primary keys value. Okay, so are we fine till here?
Just to rephrase it, Jalaj, so once the record is updated, we would delete the existing record and append the updated record, right?
That's it. And all the new records will be keep appending. That's all. Okay. No more questions. Okay. Then what's going to happen in that case of SCD2? In the case of SCD2, we are going to be picking up these records from the source that we get on the initial day or the day one. Okay. I'm here. You will have the 3 column names as well. Okay, this is your day one load and this is SCD2 logic. What is going to happen? We are going to maintain few more things here, okay? Like SCD2 contains history, okay? And it is merge and insert. You can call it merge and insert, okay? So what's going to happen here is we are also going to create few more columns, that is start date, end date, and active flag. So obviously these column names can be slightly vary, start date, end date, I am calling them. It could be insert date, update date, or it could be some different date names might be there. And same goes for this column. You can call it active flag, current flag, active indicator, current indicator, something that some logical column name that provides the state of the record. Okay. So once you insert all these records on day one, you are not going to insert only these 3 columns. You're also going to create 3 more columns at least. These columns will have details like start date, that is 26/12/2023. This is going to be same for all the records. Same way we'll have end date. You will give some hard-coded date. Okay, some date that you have discussed, 999, all zeros, all ones, all twos, like that. That is basically indicating that this record is not ended yet. And active flag is going to be Y, or it can be yes, or it can be active, it can be disactive. Something that is indicating that. So let's consider it's Y. Now on day 2, we have these records. Okay. So let's say on day 2 we'll copy and append these records here. Okay, all this new will be deleted. Same thing you will do for these records. You will maintain the history 27/12, assuming that these records came into the picture on very next day. You will paste these records. Same way you will maintain the history. Same way you'll say these are the current records or these are the active records. Now interesting thing happens for this active, this updated one. So for this record, new value will be copied. It will be pasted. Okay. And where it's the old value, 7322, where is that? 7322, this row. Okay. Now here what's going to happen for this record, you are going to maintain a end date. That means on 27th, this record was end date. Its current indicator going to be N. This complete row is going to get modified actually. Okay. And for this row, you will have start date as this one. And you will have these details as it is. Typically in SCD2, you know when a particular record was ended and when its new values was started and which is the active record. And this kind of formation is, or this kind of pattern is very much used in projects. Okay, you can say in live projects this is very much used, and you should kind of memorize this concept of SCD1 and SCD2 for sure. This is very important. Okay, you can expect a few questions around this in your interviews for sure. Okay, and they are not going to ask you like directly like what is the SCD2. I mean they can, okay, but more oftenly they are going to jumble it up, something like I'm uploading the data on daily basis. I want to keep track how many active records I have, how many total records I have, how many records I'm updating today, what records got inserted today, what records got updated today. Okay, what records are not active in my source, what records were active and when they were active, like which are active 6 months back but not active today. So what kind of problem you are trying to solve? This is all these questions are problem of SCD type CD type case study. You need to design your tables with proper slowly changing dimensions logic, and you also generate one more column, that is surrogate key. Surrogate key, just you can say it's a kind of a primary key, because now we are considering this listing ID as a primary key, but we already have duplicates here. To remove this conflict, you create surrogate key that is more oftenly is a sequential order. Okay, so previously for the record surrogate key was 12. Now the surrogate key is inactive surrogate key. I mean, it will stay. It will not get deleted. It will stay, but surrogate key 18 is the latest one for this. So I'll wait here if you have any questions.
To sum it up, Challenge, we are maintaining history in SCD type 2, right?
Yes, actually you can read some blogs, SCD types. I mean, use any one of those, but let's try to go on with updated one.
Yeah, I'm aware of this concept, but I've not worked on it.
No, this is like you have multiple types, but more oftenly these will be a crucial one, SCD type 3. Okay, till here it's very important. Okay, you don't need to type 4 and type 6. It's something very rarely used, but all these things you have to understand. Let's ping it to you. Just go through, kind of memorize this completely with examples, and not only memorize, just understand it, like how it actually works. And somebody is trying to form a question around this, you should know that this is a question of SCD. Okay. Any questions?
So as you mentioned, in this case, surrogate key would be like the primary key here, right? Because
You can
the
surrogate key and
primary key
listing
cannot
ID
be
is a primary
duplicated.
key for your table. Combination of surrogate key and listing ID, you can say. I mean, it depends on logic to logic. Like my project was treating surrogate key as a primary key only. We were doing the joins based on the primary key.
Okay.
Okay, now let's come towards the code part of this, for the solution part of this problem. So these are the libraries that I have imported. Okay, so do not worry about these things. Most of them I'll explain, and some of them I have kind of duplicated. Like this functions, I have imported multiple things. Okay, I could add a simply said this line itself in a once only. So the actual code starts from here. This is all we know, Spark context setup. The actual code starts from here. Right now, we are going to trigger our programs manually. We are not going to trigger it with the help of Lambda functions. When we are going to plan it with trigger with the Lambda functions, we are going to use this, we are going to uncomment this line and use it. I am defining my S3 input part. This is the place where my input files are being stored. S3 output path. This is the place where my output paths, output files are going to be placed. We will discuss this unload path. I mean, actually, let's discuss this. Unload path is, see, again, coming back to this sheet. When I say on day 2, like I simply seen it with my eyes and I copied these rows and I updated them here, and I copied this row and updated this at the end of my example. But for the program to do this thing, to identify which are the new rows, which is the updated rows, or which are the deleted rows, you need to compare the day 2 file with the existing state of your target table. You getting my point? To make this decisions, which rows are new records, which rows are updated records, which rows are deleted records, to make these decisions, we need to compare our source. Okay, we need to, or I should say, we need to compare our current source, the current status of our source, with the current status of our target table. That means obviously this table in the case of SAD2. Okay, that is I'm highlighting that is the below table. So we need to make comparisons between these two tables. Now in AWS Glue, there's no direct way to read the Redshift tables into data frame. I mean, there is actually, but it's more complex and less optimized way. Okay, that is why using the Spark read format, but that is much more. That is why using the JDBC connection and using the Spark read format, but it is not so optimized. So what we do, we unload the data from Redshift table to S3. Okay, so we will have a input location and unload. You can compare. This is your Redshift table. Okay, whatever the state of the current Redshift table, we are going to unload that on S3 location, and we are going to create a data frame from that. So we'll have two data frames. One from S3 input path, that is going to be source data frame. One from the unload location, that is going to be a Redshift current table status data frame. Then I have file path variable and bucket variable that I'm going to use later on. And I have IAM role ARN that I'm going to use later on. Okay. First thing that I am doing, I am creating a dynamic frame. Okay, this is something we have already seen in the AWS Glues demo, that how we read a CSV file from S3 location and create a Glues dynamic frame and convert that dynamic frame into a Sparks data frame. Okay, I am doing it. I'm using my S3 input path variable to read it from this location. Input files type is CSV, separated as comma, and rest of the things are as usual. Okay. So here I have prepared my source. Okay. I am going to convert this into a data frame. That is one different thing. Then I need to unload the data from Redshift. Okay, then I need to unload the data from Redshift and create a dynamic frame from that. So I try to create my query dynamically here. Okay, so I can use the same job for multiple things if I want, or I could at least do copy paste. So what I'm doing, I am creating a variable called table name. Okay, I'm creating a variable called table name. This is my table name on Redshift. I'm creating a variable called SQL query. In this, I try to formulate a query that is going to select the data that I want to unload from Redshift table. That basically means $. This is the syntax of unload command in Redshift. Do not get confused. It is just a syntax. I say select star from. Inside the from, I am passing my table name. So basically what I'm saying, whatever is the data in my table, take all the data for retrieval. Then I prepare one more variable, SQL unload. In this I say unload. What do you want to unload? In the first place is my SQL query will be replaced, that I've created on line number 51. My SQL query will be replaced in the unload's first argument to the location. In that, I am going to mention my unload path. So basically, I am saying unload, select star from Airbnb price details to this location that I mentioned in the above. Okay. Output thing is like some arguments I'm defining. Format is going to be Parquet. I want to clean the path before I write the new files. I want to keep my parallel state off. That means I do not want to create multiple files when I'm writing those files into S3. I just want to have a single file. And I am saying IAM role. That means what IAM role you want to use while unloading this, and that IAM role I am mentioned with the help of IAM role ARN. That is my third argument here. Okay. So basically, I am saying unload my data to location using some IAM role that has Redshift full access and S3 full access for my account. Okay. Once I unload this, see, unload basically is going to feed the data from Redshift table and it's going to create a Parquet file on S3 location that you mentioned in the location argument. Okay. Once we get that thing done, okay, I can again create a dynamic frame from the same unload path because now I have some data unloaded there in the format of Parquet files, and I can read the file there and create a data frame for me. Okay, that's I'm creating a dynamic frame for me. Okay, so I am creating a dynamic frame data source 1. For the source file, I have created data source only. Okay, so do not get confused. This is data source. This is data source 1. Okay. Now, I mean, let's just pause here. If you have any questions, still here. And guys, please ask questions because things are going to get more complex from tomorrow onwards. If you have any doubt, please ask questions. And if possible, before joining the next class, please revise this one. So you can have a link created in your mind. You guys are getting it, or you guys are completely this is went from your head. Please answer me.
I need some time to go through the recordings and all.
Okay. You can let me know if you have some doubts here.
As of now, no doubts, Jalaj.
Okay. Okay. So if you see, guys, these 3 lines, even the SQL unload is just a string variable. Okay. If I talk very basics, it is just a string variable that is having your query prepared. Before executing line number 56, okay, what I'm trying to say here, the most important line in this piece of code is line number 54. This is just a string generated, and this is you are trying to read a data. Okay, before you read the data, you actually have to execute the unload command that you have created on line number 52. Okay, that means this command should go on Redshift. It should get executed there, and to do so, we should have a proper connection with our Redshift cluster. That's getting my point. Okay. So to do so, we have this line number 54, where I say my functions dot unload data Redshift, and it takes one argument, that is SQL unload. So this is a SQL, this is a string variable, as I mentioned. It's going to take this variable that contains your query to unload the data from Redshift. It takes that variable. What it do with that? It is actually present here. And see, this is something we have already seen in the example of Kinesis, that we can have our files, that we can have our code separated from a single file. Same thing we do on AWS Glue as well. I import my function. On line number 15, you can see I am importing my functions, and my function is one more Python code. Okay, you can see here I have multiple functions defined. Okay, and the function that I have called here on line number 54 is one of them. If you search for this function here, I have it defined here. Okay, so what's going to happen once my code comes here, like it has prepared a query. Listen this very carefully. I'm not saying it is executed. I'm saying it is prepared my query on line number 52. On line number 54, it is going to execute that. Okay, it is going to call this function unload data Redshift. Control is going to come on this particular piece of code. In this variable called SQL query, I am going to receive this SQL unloads value. If you recall this from the Python classes, I have already explained this to you, that Python takes argument on positional basis. Okay, so SQL query is going to receive whatever is there in the SQL unload. You can also call it SQL unload. You can call it ABC or XYZ, whatever you want. But a point to understand here is the first argument is going to be replaced in first argument. So if I had two arguments here, then it would have been a different case. But right now, I just have one argument, so SQL unload is going to be equals to SQL query. Okay, then I create a Redshift client using the Boto 3, something that we have seen multiple times for different services. I need to pass three details. My cluster ID, it is nothing but the name of my cluster. It can be different for yours, or it can be same also. Your DB name, for free trials, your DB name is always going to be dev. RS user is by default AWS user. So while you created the Redshift cluster, if you haven't modified the username, it's going to be RS user only. Okay, so we have defined three arguments. Then using the client information, I call a function execute statement. So execute statement is a Boto 3 function. You can check out its detail on Boto 3 page. It takes few arguments such as database that we have passed it using DB name, that is dev, cluster identifier that we have passed using the cluster ID variable, that is Redshift -cluster-1 for our case. DB user is going to be your RS user, that is AWS user. And again, I'm recalling this very basic thing that you can you can name these variables as per your choices. The one in white, not in sky blue. Then it takes a SQL query. Okay, then it takes a SQL to be executed. That SQL is in SQL query that we have created on our main program, that is unload command. Okay. So on line number 59, inside the my functions, inside the unload data Redshift, your actual query is going to get executed. Okay. The response that is going to come from this execute statement is going to be saved in the response variable. Okay, and it's going to get a ID. So basically what happens whenever you submit a query on Redshift, okay, whenever you submit a query on Redshift, it gets a query ID generated. The same ID we are trying to capture from the response variable on line number 60, and we are calling a query ID or QID. Okay. Now, one thing that we need to understand here is that line number 59 is basically connecting with Redshift. It is passing our query and it is starting our query on Redshift cluster. Okay, it is not going to utilize the resources available on AWS Glue. It is going to utilize the resources available on Redshift cluster. Okay, and once this query gets once this line get executed, your control is going to come back and it's going to get started with the line number 56. Okay, but what if, and there is very general case, okay, because this query will need its own time. Let's say the data size is huge, it might take 10 minutes, but your Glue is going to execute this statement, query is still running on Redshift, and your control is back here in, and this is going to happen in the 1 second only. I mean, 1 second is a huge time I'm saying, okay? Not even the 1 second. In next few milliseconds only, once you call this function, your code is going to try to read the file from this location, but your query is still running, okay? Your query is still running on the Redshift cluster. It still has not generated the data. So to avoid such situations, we have to mandatorily write a loop that we have done starting from line number 62. Okay, I have created a variable done equals to false. That means I am saying while not false. Basically, I am saying a infinite while loop. I am starting a infinite while loop that is going to use the describe statement function of Redshift's client's Boto3 library. It's going to take one argument, it is query ID, and it's going to have various details there that you can check on the Boto3 page. One of that status is status. Okay, one of those options or one of those responses that describe a statement produced for you is status. Okay, so we are actually checking the status in the next few lines. If the status is failed, I am going to print the message on my logs on CloudWatch that status of the query ID is this. Okay, on line number 67, I'm saying those details. If the status is failed, simply put the query ID and status and print the message like whatever the query ID. Let's say query ID is 123 and status is failed. The same message is going to get printed on my CloudWatch logs. Line number 68, I'm raising the exception. Okay, exception in the programming, you can say it's an error catching. It's kind of a catching the error, or it's kind of a you can also say like failing the code intentionally. So see guys, even if this loop even if the status is failed, you can print this, but this code is going to get executed on the code is still going to move forward and gets executed, and that is something we do not want. Okay, what we want is if the status of our unload query is failed, we want to raise the exception and we want to fail our glue code as well. Okay, you should understand this connection. If your Redshift query is failed that you started on the line number 59, if that is failed, you cannot go ahead with the AWS Glue's code execution. We have to fail this as well. Okay, so same thing we are trying to do on line number 66 to line number 69. We are going to raise the exception if the status of the query is failed, and same kind of thing we are doing from line number 70. If the status is finished, Okay, if the status is finished, then we are printing the status and we are breaking the loop. So break statement breaks this while loop. Okay, break statement breaks this while loop. Now this function define unload data redshift is completely executed, and now your code control is going to come back on line number 54. And as we have waited that time, okay, so let's say the query takes 10 minutes, so till 10 minutes it's going to run this while loop, it's going to look for the status, and then it's going to come out of this loop and going to execute the next line, that is creating a dynamic frame from your unloaded data. So this is the complete process that we are doing inside this one single call, that is whole that call is defined here. So now I will take a pause. I'll take a break here. If you have any questions in the process or the reason or the code, you can let me know.
Can you go to this other code? Okay, Chalish. So I have understood so far.
Actually, this is the all from my end from today. So if you have any questions, you can ask. Otherwise, we are going to wrap it up today and continue from here tomorrow. And as I mentioned, please, keep all these things in your mind. Have a refresher before joining the next call tomorrow.
Okay.
Ritesh, are you good?
Yes, I am. As of now, I'm good. I will definitely go through the recordings once again because tons of information I need to understand.
Yeah.
Jared, one question. Uh, did we cover anything on airflow, or that is not required as of now?
No, airflow is actually not mandatory thing, and actually it is not covered in this course as well.
Okay.
Airflow is something that you use majorly on Hadoop systems.
Okay.
On cloud, you can completely skip it. Airflow. Be it on Azure cloud or be it on AWS cloud, you can completely skip airflow.
Okay. So, do you also train people on Azure part, Azure data engineer?
Yeah, I do.
Okay.
Okay, so we'll meet tomorrow at the same time. Thank you guys. Have a good day. Bye-bye.
Thank you, everyone.
Thank you all.